Good morning, fellow mathematicians, and welcome to another Year 7 lesson on directed number. So if you can just with your ruler draw off a line from the previous work you've done, pop in today's date, and the title will be Evaluating Expressions. Your do now task for today is to use each number card, which are -5, 7, -2 and 10, and any operation, so looking at adding, subtracting, multiplying and dividing. Can you make each of the target numbers below, the numbers being 20, 250, 42 and -40, and then can you find more than one way perhaps to make those as well. So if you pause the video at this moment, give yourself 5 minutes, and then we'll come back and see how we got along. Okay, welcome back then. So hopefully we've found at least sort of one way to make each of those numbers. Obviously there's loads of different methods you could use, so I'll just run you through a quick example for each one. Perhaps to make 20, you could have gone with -5 and squared it, so -5 times -5 gets us to 25. And then if you do 10 divided by -2, that gets you -5. If you were to add 25 and -5 together, you would get 20. For 250, again, I chose to do -5 squared, getting us to positive 25, and then simply multiply that by 10 to get to 250. 42, I went with 7 squared, which is 49. Then if I added a -5, that's actually going to make it smaller, getting us to 44. Then adding again -2, adding a negative number makes that smaller, that gets us to 42 that we're after. Last one, -40, I went with -2 times 10, which is -20. And then if I did -5 plus 7, I get to 2. Now to multiply those two together, -20 times 2 leaves us on -40. Well done if you found more than one way on some of those. So one of the focuses we're going to look at today is the term BIDMAS. Now hopefully you've all come across that before, and I would like you first to pause it now and see if you can remember what each of the letters of BIDMAS represents. I'll give you a little hint. It's to do with the order of operations. Okay, well hopefully you've been able to fill in most of those letters. The second letter, the I, is the one where most people will slip up on. Perhaps you might know what it means once you've seen the word, but let's have a quick look for you then. So this little trapezium on the bottom left that we've come up here tells the order you must do the calculations in. Now on the next slide it's going to appear again, and I'm going to give you a chance to copy that down. So BIDMAS, first of all, the B stands for brackets, I for indices. Now, indices are the one that most people will struggle with and perhaps struggle to remember. Indices are your powers. So that's the little number that goes above. So, for example, when we say 2 squared, that little 2 in the top right there above it is your indice. It's your index number. Indices are simply the plural of index. Okay, so that could be squaring a number or perhaps even square rooting, cubing or cube rooting. D is for division, M for multiplication, A for addition, S for subtraction, and it's your order of operations. So you work from the top B all the way down to S last, working through in that order through a calculation. Okay, so there's your trapezium again there as well to show that, your brackets, your indices, division, multiplication, addition and subtraction. If you now pause the video on those and make sure you've got both those information down, the writing and then that diagram alongside to make it clear. Now you've got those down, we need to see why we have these order operations and how that affects our working. So today's job is we're going to look at the order of operations, so using BIDMAS, evaluate simple algebraic expressions, and then we'll look at moving on to more complex algebraic expressions after that. So if we have a look at this sum here, 3 plus 4 times 5. Now, the whole order of operations tells us what we need to do first, rather than simply going from left to right. Most commonly, people would do 3 plus 4, 7 times by 5, and get to 35. That is wrong. We know from BIDMAS now, there's no brackets, there's no indices, there's no division, but then M, multiplication, there is a multiplication, so we would do that first. So we would do 4 times 5, which is 20, then add the 3, and we will get 23. Now, if you pop that into your calculator as well, exactly as it appears, your calculator will give you the answer of 23, as your calculator knows the correct order to work in as well. Okay, so we're going to have a look at examples of how to use BIDMAS now. And a good tactic, certainly at the beginning, is to underline the bit you're going to do first, then rewrite it with that done, and then you can work your way through correctly. So here's a few examples. So on this one, we've got the brackets as 3 plus 4, so brackets B, first bit of BIDMAS, that's what we're going to do first. 3 plus 4 is 7, then we're going to multiply by 2, and we will get to 14. Next up, 3 plus 4 times 2, we're going to do again multiplication first. 4 times 2 is 8, add the 3, and we'll get to 11. Now this is our first look at our indices, so our powers. 3 squared comes first, it comes before the M for multiplication in BIDMAS, so we do 3 squared first, 3 times 3, which is 9, then multiply it by 4, and we'll get an answer of 36. Now this one looks a little bit more complicated. We've got 4 terms in a row, and we're going to go right in the middle here with the multiplication first. It asks us to do 4 times 3, which is 12. Bring the other 2 terms down exactly as they are. 3 plus 12, then take away 2, gets us to 13. Okay. If in fact you did it the other way around, you went 12 minus 2, then added 3, you would still get to 13 on that one. Next one. Brackets first, 5 minus 3 is 2. It asks us then, let's bring down first, the next terms. We then need to square it. I next, indices. 2 squared is 4. Bring the next terms down. 3 times 4 is 12, then minus the 2, and we'll get an answer of 10. Okay. So I'm going to put up a few quickfire questions. What I'd like you to do is, as these questions appear, you're going to write these down in your book exactly as they are shown. Pause it, give yourself 30 seconds to answer it, and then we'll come back and look at the answer. So first up, 6 plus 4 times 3, 30 seconds, give it a go. Okay, so on this one, I think the common answers we may potentially be getting in this room will be 30 and 72. Those who got 30, you may have gone with 6 plus 4, then times by 3. Or 72, perhaps you've misread and gone 6 times 4 times 3. We should be looking at this one, is the M comes first from multiplication. 4 times 3 is 12, then add the 6. So we should be getting 18 for that one. Same for the next one. If you write that down, pause the video and give yourself about 30 seconds though to answer that, and we'll see how we did. Okay, so 10 minus 8 divided by 2, we'll do division first. 8 divided by 2 is 4, 10 minus 4 will get us to 6. We're not going to do 10 minus 8, which is 2, then do the division to get the answer of 1. We'll do division straight away. Third one. Pause it again there. Give yourself 30 seconds and we'll see how we did. Okay, so we've got multiplication and indices and addition this time. Indices comes first in the order of BIDMAS. So we'll do 3 squared first, which is 9. Then we'll multiply it by 4, it's 36. Add 1 and we should get to 37. Next up, 20 minus 4 and then plus 10. Okay, on this one we should get an answer of 26. 20 minus 4 is 16, plus 10 is 26. The addition and subtraction here, actually, if you pick some different orders, it wouldn't matter. If you did 20 plus 10 first, you'd get 30, then took away the 4, you'd still get 26. You've got to pay careful attention, though, as to which numbers you're taking away. Don't think you can swap the add and subtract around for 4 and 10. Okay, Tim's had a little go at a question here. He's got 3 plus 4 times 3 plus 1 and put it's equal to 19. First of all, I would like you to have a go at redoing that and telling me what the correct answer should be. And then, using his answer of 19, can you add in a single pair of brackets to make 19 correct as the answer? So again, if you pause the video there, give yourself a minute or two to see if you can get those parts for me. Okay, so looking at this then, Tim has got it wrong with an answer of 19, because we know from BIDMAS we'll do the multiplication. So 4 times 3 is 12, add 3, 15, add 1 is 16. So the correct answer would be 16 for that. But if we wanted to be the answer 19, could we put on some brackets to make that correct? If we added them in on the 3 plus 1, we would do the 3 plus 1 first as the brackets, which is 4, then the multiplication. 4 times 4 is 16, then add 3 gets us to 19. So make sure if you got that correct, fantastic, well done. If not, make sure you've got that in your book as well to show the importance of brackets and how it can change an answer completely. Next up, we've got some purposeful practice. So I'd like you to work your way through from left to right, starting on section A, section B and section C. You'll need to write the question out fully and then tell me what that would be equal to. And I would like as well to see you underlining the bit you would do first. So say, for example, on section A, question 1, 3 plus 3 in brackets times by 4. You would underline 3 plus 3 because that is the brackets. That's the first thing you will do. And then you would multiply. Okay, so if you pause the video at this moment, give yourself enough time, I reckon around about 10 minutes, and you should be able to do those 3 sections for me. Then, when you complete them all, start the video again and we'll put the answers up for you. Welcome back then, so hopefully you've had a good go at those, and the answers will be appearing for each section now. If you can mark your work in your book for me, please, and then give yourself a little score for each section. So section A out of 8, section B out of 7, and section C is out of 6. Well done if you got most of those right, especially on section C there as they start to get a little bit more challenging. Okay, next up we've got a little bit more practice to do with these, and this time we're looking a lot more at negative numbers as well. So you need to be very careful on how you can remember the rules of adding and subtracting negative numbers, multiplying and dividing them as well. So if the signs are the same on multiplication and division, then the answer will always be positive. So say, for example, we have positive 18 divided by positive 3. Both the signs are the same, so you would end up with positive 6. If it was minus 18 divided by minus 3, again, the signs are the same, so the answer would be positive 6. Okay? If the signs are different, for the top left example, positive 18 divided by minus 3, the signs are different, one's a positive, one's a negative, then the answer will be negative, so that would be minus 6. So once again, if you pause the video here, write those questions out fully for me, and then give those a go. Welcome back then. Hopefully we've had a good go at those, so I'm going to put up the answers for you now. So first one should be 15, then minus 13. We can do the top of the fraction there first, so 21 plus 18, 39, divided by minus 3 is minus 13. Then minus 14, 32, minus 8, 64, 13 and 1. Okay, it's worth looking at the top right, the right-hand side section, the minus 8 and 64 as the answers, as to what that subtle difference means with those brackets. Now we know a negative multiplied by a negative makes a positive. So on that second one, where we have minus 6 in the brackets, it's then squared. We've got minus 6 times minus 6, which gives us a positive 36. On the one above it, it's minus 6 without brackets squared. So you do the indices first, which is 6. 6 squared is 36. then the negative comes back in. So that actually becomes minus 36 plus, and then 14 times 2 is 28. So minus 36 plus 28, whereas the other one is minus 6. All of that is squared. Minus 6 times minus 6, so we get 64. Okay, it's very important to have a placement on brackets, especially for indices there as well, which we may show a little bit more further on. Okay, so going back to the mistake I believe it was Tim that made, where we put in a set of brackets to make that correct, you're now going to have a go at these. So don't change what the answer is. So 3 plus 1 times 5, we're saying the answer is 20. But the left-hand side, the 3 plus 1 times 5, that doesn't make 20 as it is. So you're going to need to insert one set of brackets to then make that equation correct. Okay, now the challenge questions below do get quite tricky, but have a go at the first set, and then by all means you can have a right good go at the challenge as well and see how you get along. So if you pause the video now, and then we'll come back and look at some answers. Welcome back then. So hopefully you had a go at those and inserted a few brackets and tested it. You may have not got it right first of all and played around with a little bit. Hopefully, though, we've got a few of these right. So first section, excuse the highbrow technology there. I had to use paint to insert those, and perhaps my hand was not quite as steady as I thought when I was doing those, but hopefully you can still see clearly enough those brackets. Okay, and that then makes them true. So you do, for example, on that first one, 3 plus 1, you do that first around the brackets, that makes 4. Then we multiply it by 5, makes 20. That is now true. Challenge questions. Again, brackets appear there for you. If you can mark any of the work you've done, actually on a couple of those, it looks like you may need double brackets. So for example, on the third one down, on the left-hand side section of the challenge questions, okay, with those 2 sets of brackets there, you would do the 7 minus 4 first, which is 3. Then multiply it by 2, 6. Then you've got the squaring of that. 6 times 6 is 36, plus the 4 gets us to 40. Okay, really well done if you got some of those challenge questions right. They were very tricky. Okay, now I like these questions. We have got 3 students having a go at the same calculation there. It's 5 minus 3 squared, in brackets, divided by 8. We've got 3 different answers. Okay, student 1, student 2, and student 3. I would like you to pause the video in a moment, have a look over which one of those has done the correct working. Have they followed BIDMAS? Have they known what they're doing with negative numbers? And only one of those students can be correct. So pause the video now, give yourself a few minutes, 3 maximum, to see which one is correct, and also to identify where they made their mistake. Okay, welcome back. So let's have a look from left to right to see how we did then. So student 1, they've gone with what their mistake is, because this is in fact wrong, is they've done 5 minus 3 first. Okay, that's got them 2. They've then squared that to get 4, then divided by 8 and to get 0.5. Okay, what you should do first is the indices. We need to do the brackets, but we've got the indice in there. That's 3 squared, which is 9. 5 minus 9 is minus 4, then divided by 8 is minus 0.5. So in fact, student 3 is correct there. Student 2 made the mistake. They did the indices, 5 minus 9, but then they ignored the brackets and they did 9 divided by 8, which got them the 1.125, then did 5 minus that. So student 3 would be correct there. Well done for those who got that. Okay, this time we can look at a little bit of substitution. Again, we're going to be focusing on negative numbers in a moment, but first of all, I want you to have a go at these following expressions when n equals 5. So you're going to do substitution when n is 5, put it into all of these values. So for example, when it goes out to the top there, 3n, n is 5, so it's 3 times 5 would be 15. Okay, so if you pause the video there and write down those calculations in your book. You don't need to set them out exactly as it is there. You can write them as individual calculations, one after each other, rather than that diagram. But if you pause it there, I'll pop up some answers in one moment. Okay, welcome back then. So n equals 5. Again, with my fantastic use of technology, I've attempted to insert some answers. If you could mark these for me now, please. Okay, now we're going to take it up to the next level, and we're going to use, instead, n is no longer going to be equal to 5. I'd like n to equal minus 4. Now, to make things easier, you must put a bracket around the negative in your working. So as an example here, 2n plus 8, when n is minus 4, we've got 2 multiplied by minus 4. I'll put that in brackets to make it even clearer, then adding 8 to it. So 2 times minus 4 is minus 8, add 8 would get us to 0. So if you have a go now on those same questions, but instead swap n equals 5 for now n equals minus 4, and put those brackets around to show your working. Okay, if you pause the video now, and again we'll have some answers in a moment. Right, welcome back then. So again, technology as it appears now, n equals minus 4, that's what we should be getting. Okay, lost it a little bit on some of the zeros, but hopefully you can read those numbers clearly enough to be able to mark your work there. Okay, so we touched on this a little bit earlier in this lesson, but Tommy has now made a mistake. He's gone with x equals 3 and y equals minus 5 into the expression x minus y squared. And he's got an answer of 28. But he has made a little bit of a mistake. What did we have a look at that was especially useful on the previous slide, but perhaps help Tommy in this scenario? Like I say, we did touch on it a little bit earlier in the lesson as well. So if you just pause it there, give yourself 30 seconds to think about that, and then we'll see how you did. Now, the hint here was the important point from the previous slide. So if we just went briefly backwards, if we look in the bottom right here, we said about putting some brackets around the negative in your working. So if we were to do this, when it's minus y squared, we want the brackets around the minus 5, because that's what y is. And minus 5 squared is minus 5 times minus 5, which is positive 25. That then would change the calculation to be 3 minus 25, which would get us to minus 22. Okay. What they've done is they've done the 5 squared, which is 25, then put the negative in afterwards. So to not make that mistake in the future, they will need to put brackets, Tommy would, around the minus 5. Okay, so always put brackets around negative numbers that are substituted into an expression. Makes the whole thing a lot simpler for you. So when it says evaluate expressions, it simply means, again, work out. So we're going to be looking at substitutions. This time A is 5, B is minus 3, C equals minus 1, and D equals 0. Okay, so if you use those figures, if you write them down clearly in your book, A equals 5, B equals minus 3, C equals minus 1, and D equals 0, then write out your questions, A minus B, put your numbers in, and put any brackets around, in particular, B and C, because they are negative ones that we want to put brackets around for substitution. Okay, so if you pause the video there, and then we'll come back in a moment and check on your answers again. Okay, so hopefully you've worked your way through those, and I want to see a lot of brackets in people's exercise books for this, and you should get the following answers. And I've just shown a little bit of our working there to see how we'd have got them as well. So we'd have got with 8 for the first one. Some of you may have gone down the page. I've just gone left to right. 0, 1, 24, 0, minus 2, minus 24, and then that last bottom right one is minus 11. Okay, now there's an extra bit of a challenge right at the bottom for a lot of you to have a go at here. So using the same values of the A, B, C and D, so A is 5, B equals -3 and so on, I'd like you to write an algebraic expression that gives the values below. 1, 10, -10 and 55. So, don't want you to use, for example, for the second one, the answer of 10. I don't want you to write 5 times 2. A was 5, so if perhaps you went with 5 times 2, that's 10, you'd use A instead. You'd write A times 2, which hopefully we know in algebra we would write as 2A equals 10. So there's quite a lot of different answers you could have for those algebra expressions, but if you pause it there, have a go and see how many you can come out with for 1, 10, -10 and 55. Okay, hopefully you've had a good go at those. If you just leave those in your book for now, and then we can sort of have a look at those at another time, because I'm conscious there are a lot of different answers for that, but you can hopefully check by substituting in yourselves afterwards that those are in fact correct. Okay, a little bit more personal practice, and again the focus is going to be on positive and negative integers, integers being our whole numbers, and substituting those in. So left hand side, questions 1 to 8, we've got x equals 4 is the substitution, so we're putting in a positive integer. Then questions 9 to 20, we're putting x equals -3. Now on the right hand side, there is a little bit of a hint there for you, and it's worth writing that box down fully for me, please, where it says remember. So an add, so 2 adds together makes a positive number, and then you've got the other 3 after it as well as your rules. So like we said earlier, if the signs are the same, then the answer will be positive. So that's the top and the bottom one. And if the signs are different, then the answer will be negative. Those are your middle 2 calculations. But if you write those down in your book and put a nice big box around it to make it clear, that's going to help you answer these. So if you pause the video there, have a go at those 20. Just be very careful. The first 8, x equals 4, and then the remaining questions 9 to 20, x equals -3. Hopefully we've had a good go at those now, and the answers will be appearing once again. So if you can just mark each section for me. So first section is out of 8, those are your answers there. Second section out of 12, and mark those for me as well, please. Okay, this time we're going with the same sort of idea. We're going to substitute positive integers into these expressions, but this time we've made them a little bit more complicated, where we've put indices in, we've put some powers. So again, on the right hand side, there's a little bit of a clue there. X squared means x multiplied by itself. X cubed, x multiplied by itself, then itself again. So for example, on the left hand side, questions 1 to 8, we're told x equals 2. That's the substitution we're going to do. So x squared would mean 2 by 2. X cubed would mean 2 multiplied by 2 again. Okay, so be very careful and think of your rules of BIDMAS. What are you going to do first? We should be doing the indices before we do any multiplication. Okay, so if you pause the video now, first 8 questions, x equals 2. For the second batch of 8, you've got x equals 5. Again, write the question out, show your full working, and then have a final answer for me, please. Okay, welcome on then. So here are the answers now appearing for you. Questions 1 to 8, and then questions 9 to 16. Okay, it's just worth mentioning, for example, on question 4. If we look at question 4, it's 6x squared minus 7. Now, our rule tells us that we will do the indices first, which is x squared. X is 2, 2 squared is 4, then we would do the multiplication. So 4 times by 6 is 24, then minus 7 gets us to 17. Okay, there's a few like that, but you would make sure that you do the power, the indices first, both the x squared and then later on questions 7 and 8, you do the x cubed first. 2 times 2 times 2, which is 8, multiplied by 2, 16, plus 9 gets us to 25. Okay. And the last bit we're going to have a look at here is there's 4 substitutions I'd like you to do into the expressions below. So first of all, you're going to put n equals 1 into those. Fill in the table as it is with the output, and then you're going to have a look at substituting in n equals 2, n equals 3, and then n equals 4 into the expressions. Okay, and I want you to see from those, when you substitute those in, are any of those sequences linear? Now, I think it was the very start of the year we looked at sequences, so hopefully you can remember what linear means. It was sometimes referred to as well as an arithmetic sequence. So, if you're unsure, look back into your book for some revision on that, and I would rewrite that definition and see what you've got as your sequence. So if you pause the video there, substitute those numbers in for me, and then see, are any of those linear? Okay, well, welcome back then, and looking at this now then, if we have to substitute 1, 2, 3 and 4 into the expressions, let's see, on the left hand side, when n equals 1, we'd have 1 minus 5, which is minus 4, times by 3 gets us to minus 12. Then when n equals 2, we get 2 minus 5 is minus 3, times 3 is minus 9, substitute 3 in, 3 minus 5 is minus 2, times 3, minus 6, and then finally with 4, 4 minus 5, minus 1, times by 3 is minus 3. So we should have left to right as our outputs, minus 12, minus 9, minus 6, minus 3. Hopefully there we can see there's a little bit of a pattern, that each time we are adding 3, okay, the number's getting larger each time, minus 12, minus 9, minus 6, and minus 3. So that would in fact be a linear sequence. So a linear sequence is there is a constant difference between them. Okay, and that constant difference will be an adding or subtracting one, and in this case we are adding 3 every single time, so that would be a linear sequence. For the right hand side, 3 multiplied by n minus 5, which is squared, we should get, when we put 1 in, 1 minus 5 is minus 4. Squaring that, minus 4 times minus 4 would be positive. That would get us to 16, multiplied by 3, 48. Putting 2 in, 2 minus 5 is minus 3. Minus 3 then squared is 9, times 3 is 27. And finally 3 squared, minus 5 is minus 2. Square that is 4, times by 3 is 12. Then 4 minus 5 minus 1 squared, minus 1 times minus 1 is positive 1, times by 3 gets us simply to 3. So we should have left to right reading on that one, 48, 27, 12 and 3. Now the difference between them, 48 to 27 is minus 21, 27 to 12 is minus 15, and then 12 to 3 is minus 9. So there is no common difference between them. Yes, they're getting smaller each time, but it's not by exactly the same amount, so that is not a linear sequence. There is, however, a different name for that sequence. So for those that you can remember all the way back to sequences, I want you to see in your books if you can write down what that sequence is called. Okay, so that does end the lesson for today on evaluating expressions. There are 2 worksheets that are then in this folder for you to work your way through as well. Now again, we have put the answer ones in there, but please make sure you work your way fully through the worksheet, showing all working before you mark it. Okay, and then if you carry on with the rest of the work that's been set and look at the appropriate Heggerty clips and answer those quizzes, that'll be what's submitted to your classroom teacher. Okay, thanks very much for listening again then, Year 7, and best of luck with it all, and look after yourselves out there.